Welcome back to Talk Tensors. Ready to dive into another fascinating paper?
Absolutely. Always excited to see what's new in the world of machine learning.
Well, today we're looking at consistent flow distillation for text to 3D generation. This one's making some serious waves.
Oh, yeah, this is a big one. Bridging that gap between 2D and 3D, it's really impressive.
Right. So think about it like this. You're trying to create a 3D model, let's say a dragon, from just a text description. Older methods, like SDS, it was like sculpting with a blurry picture.
You get the rough shape, but the details, the nuance, it's all fuzzy.
Exactly. And SDS would try to find like a single best guess for the 3D model.
Which, yeah, that really limits the detail and the variations you can get.
But CFD, consistent flow distillation, it changes the game. It uses diffusion models, those things that have been revolutionizing image generation.
Diffusion models, they're incredible.
Instead of that blurry picture, CFD uses a bunch of super sharp images, all from different angles, to guide the 3D model creation.
Like having a team of photographers capturing every single detail. You get a much richer 3D object. More variety, too.
Now, the paper talks about this multi-view consistent Gaussian noise. What's that all about?
Okay, so imagine you wrap this dragon in noisy paper. From one angle, the noise looks random. But look from multiple angles, and suddenly the noise aligns with the dragon's surface.
It's like the noise itself is defining the shape.
In a way, yeah. CFD has this algorithm that projects points on the object onto a reference space, keeps the noise consistent across all viewpoints. That's key.
So smooth, accurate 3D models. It really seems like a huge step forward. Can you give us a bit of the background how we got here?
Well, like I said, diffusion models are at the heart of this. They add noise to an image gradually, then train a model to reverse it. Imagine mixing ink into water, drop by drop, then figuring out how to separate them again.
Oh, that's wild.
It is, right. And then you have the 3D side. To make a 3D object, you need a mathematical representation. That's where things like neural radiance fields, NeurRFs come in. They're like digital clay.
So the nerves give the structure, and the diffusion models do the sculpting.
Precisely.
Okay, so what are the big advantages of CFD over what we had before?
Well, you get three main things: quality, diversity, and efficiency. You get better detail, more realistic appearance, a wider range of objects from the same text prompt, and it's just as fast as SDS.
Like a supercharged 3D printer.
In a way, yeah.
The examples they show in the paper are pretty amazing. You've got treasure chests full of gold coins, toy fighter planes, even a steampunk owl with mechanical wings.
The level of detail is remarkable.
It's stunning visually, but what about the bigger picture? Where could we use this?
Oh, the applications are huge. Video games, virtual reality, even scientific visualization. Imagine creating entire 3D worlds just from a description.
Building virtual universes with just your words. Could this make 3D content creation accessible to, people who aren't hardcore tech experts?
That's a great question. And it looks like the answer is yes. CFD uses those pre-trained 2D diffusion models that are already out there. No need to start from scratch.
So it could democratize the whole process.
Potentially, yeah. Anyone with a creative spark could bring their 3D ideas to life.
And this is where we come to our favorite part, the novel notions segment.
Time to speculate a bit. I like it.
So we've got CFD generating the shape of the object from text. But what if we could get the texture too? Imagine typing a weathered oak table with a hand-carved floral design, and then seeing not just the shape, but that aged wood, those intricate carvings, all in 3D.
That's an amazing thought. We're seeing such amazing progress in image synthesis and texture generation. Could we merge that with CFD? Realistic, customizable 3D textures.
You could feel the grain of the wood, the sharpness of the tools, all from the text. Think of the realism we could add to games and virtual environments.
That raises a really interesting point. How do we make sure those textures aren't just pretty, but actually physically accurate? That's a challenge worth exploring.
Absolutely. This whole deep dive into CFD has been incredible. We've gone from the basics to imagining all these possibilities. Now, to really understand the impact, let's step back and look at the history, the innovations that led to this moment.
Yeah, that context is crucial. It really is building on the work of so many brilliant minds, both in 2D and 3D. Years of innovation.
Standing on the shoulders of giants, right?
Yeah.
So what are some of those milestones that paved the way?
Well, you can't talk about this without mentioning diffusion models. They've totally changed the game for image generation, creating photorealistic images from pure noise. A few years ago, we wouldn't have believed it.
It's like, those time lapses where you see a painting come together from these random brushstrokes, except here the brushstrokes are algorithms.
And it's not just art. This has implications for science, medicine, all sorts of fields.
And on the 3D side, what advancements led us here?
The development of differentiable representations, things like NeurIFs, has been huge. They've brought so much smoothness, so much detail to the 3D world compared to the old blocky models.
Yeah, it's night and day, like building a castle out of Legos versus sculpting it from clay.
Exactly. And this paper, it brings those two worlds together, the 2D image generation and the 3D representation. That's the magic.
A real fusion of ideas. So by using diffusion models to guide the way we shape those 3D representations, we get this amazing quality and diversity.
Right, it's pushing boundaries.
Now, this paper focuses on text to 3D. But could these same principles apply to, say, audio or touch? Could you create a 3D model based on sound or how a surface feels?
That's a really interesting thought. The underlying idea, it could potentially extend to other modalities. The tricky part is figuring out how to encode that information, the sound or the touch, in a way that can guide the 3D creation process.
Multisensory 3D content creation. It blurred the lines even further between physical and digital.
Definitely. And another important aspect here is accessibility. We touched on it earlier, but it's worth digging into.
Yeah, for sure. Creating good 3D content has traditionally required a lot of specialized skills, expensive software.
Right, but by using those pre-trained 2D diffusion models, CFD makes things a lot easier. Imagine anyone with a laptop could create their own 3D masterpieces.
It'd be incredible to see what people could come up with. A whole wave of creativity.
It's exciting, but of course there are challenges, limitations to consider too.
Right. Every technology has its hurdles. So what are we up against with CFD?
One big one is making sure those 3D objects aren't just pretty, but that they could actually exist. You have to consider gravity, material properties, all those real-world physics things.
It's like you can sculpt a beautiful statue, but engineering a working machine, that's a whole other level.
Exactly. We want to create objects that have real-world value, that could even be brought into the physical world someday.
That's a great point. Okay, so we've covered the history, the potential, the challenges. Now I think it's time for our Novel Notions segment, where we get to speculate a bit.
Always a fun part. Let's see what we can dream up.
So CFD generates static 3D objects from text. But could we take it a step further? Could we generate dynamic 3D animations from text? Imagine you type a hummingbird flitting between flowers, its iridescent feathers shimmering in the sunlight, and you see that whole scene come to life in 3D.
Wow, now that would be something. It's like those crystal clear snapshots we talked about, but stitched together into a movie. All guided by your words.
Text to 3D animation. What would it take to make that happen?
Well, it'd be a pretty big research undertaking, combining advances in a lot of different areas. You'd need to upgrade CFD to handle temporal dynamics, generate sequences of frames that flow smoothly.
So instead of optimizing one 3D model, you're optimizing a whole series of them, each one a different moment in the animation.
Exactly. And you'd need new algorithms to make sure those frames are consistent, that the motion looks believable, the hummingbird's wings would need to flap right, its body would have to move smoothly, the feathers would need to shimmer.
There's a lot to it, but we could learn from what's already happening with video generation using diffusion models. People are already generating video clips from text.
That's true. There's a lot we can borrow from there. But another big challenge would be capturing those subtle details. The hummingbird's behavior, how it hovers, how it darts around, all those intricate movements.
You'd need to go beyond just smooth movement. Incorporate physics, biomechanics to make it look real.
Right, like you're creating a digital puppet that behaves just like the real thing. You'd need motion capture data, simulations, maybe even go out and observe real hummingbirds.
So it's complex, but think about the possibilities. Animated movies from just a script, interacting with lifelike creatures in VR.
And educational applications, too. Imagine bringing complex scientific concepts to life, making them way more engaging.
It's mind-blowing to think about what text to 3D animation could do, how we tell stories, how we learn, how we experience the world around us.
It really is a groundbreaking area of research. I'm excited to see where it goes. It's incredible to think how this could change everything. Entertainment, education, you name it. But we also have to talk about, the ethics of it all.
Right. With any powerful tech, there's always the potential for misuse. So what are some of the ethical things we need to think about with text to 3D animation?
As this gets more advanced, we have to be careful about, misleading content. Think about fake news footage, deep fakes, things that could really damage someone.
Yeah, that's a serious issue. We need to be responsible with this, anticipate problems, build in safeguards.
Exactly. Guide its development in a way that benefits society and minimizes harm.
Absolutely. Well, we've covered a lot of ground today. From the basics of how CFD works to all these incredible possibilities for the future, it's clear this tech has the potential to revolutionize a lot of fields.
It's been a fascinating deep dive, that's for sure. We saw how it builds on years of research, and then, well, we let our imaginations run wild a bit.
And speaking of running wild, we should remind everyone that our Novel Notions segment, that's all speculation, just brainstorming, not making predictions.
Right, just throwing out ideas, sparking some more exploration.
So, there you have it, our deep dive into consistent flow distillation and how it could change the world of 3D content creation.
It's going to be exciting to see what amazing creations come out of this as it evolves.
Until next time, keep those creative gears turning, and we'll catch you on the next Talk Tensors Deep Dive.
Stay curious.